Alright, this is just a quick video on some help with the lab. So I sent this to our professor. I think everybody got this email. You can open up this, and here's all the basic code. You can copy that, go into our project. I have a new project pulled up already. Here's the code right here. We can save it. We can build it. Here you can see that the A5 LED is on. Okay, now to add to this, we're going to add the turning off the LED as well. So this is the bit set right here. I can make a comment, turn LED. The code we just ran, it turns on the LED, and the very next instruction turns it off. So if we click reset, we should be able to see the program run again, but it's running so fast that we can't even see the LED go on. So now we're going to add a delay. In order to add a delay, we need to first have the delay value that we can then subtract later. So we can look here, we can name this delay value 1, and then EQU, that is the syntax, and then we have to define a register location. So if we go to the data sheet here, we can go over to this side right here, and we can go down to memory organization. Now if you scroll down, where is this correct? Let's see. Here we go. We have this. This is the total memory bank. We can see that there's general purpose RAM, but this actually has to do with banks. This area right here, common RAM, it's pretty easy to remember. It starts at 70. So we will just start with 70. So if you go to the code here, we can just define this being at 0x70. That is not saying that delay value 1 equals 70. It's just saying it's at memory location 70. Now, when we go into our code, we can create a new label right here. We can call it delay loop. And starting off, our delay value doesn't have any value at all. So in order to get a value in there, first we use the command move LW. This moves a literal, which is some sort of number, whether it be binary, hexadecimal, whatever. A literal, it just means a number. So we can move the literal 0xFF, which is in hexadecimal, that's 255, to the W register. This is the working register, and if you took computer architecture, we refer to it as an accumulator. It's essentially the register that's connected to a lot of like the things like the ALU, and it's the most general, easy to use register. Our next command that we can use is called move WF, and if you ever see the letter F, that's referring to a named register or some sort of location. So in our example, this is move WF moves from W, which is that working register we just defined, to F. So our F value that we want is delay value 1. After this, for good measure, we can put a no operation that provides, I'm not sure if that's entirely needed. This is with our delay code running, and we can see that this light is still on all the time. The delay loop appeared like it didn't work, and I believe that is because the delay is just not long enough. So there's a quick fix for that. Well, in an actual program, you would want to extend this delay loop. Since we're just debugging and learning here, a good technique would be to, if our theory is that the loop is just not lasting long enough, we can copy and paste these delay loops and just do a ton of them and see if that's working. Let's see. So I actually added a few more delay loops by copy and pasting because it wasn't showing up on my camera well. But there's the final result blinking. As I mentioned earlier, ideally you would not want to copy and paste the call delay loop hundreds of times, but on my final lab, I was just able to extend the delay function to actually work on 3 separate delay values at one time, because the highest number you can make it is 255, so I had to use 3 separate variables.